In the prequel to this course, we computed summary statistics of measurements, including the mean, median, and standard deviation. But remember, we need to think probabilistically. What if we acquired the data again? Would we get the same mean, the same median, the same standard deviation? Probably not. In inference problems, it is rare that we are interested in the result of a single measurement or data acquisition. We want to say something more general. Michelson was not interested in what the measured speed of light was in the specific 100 measurements conducted in the summer of 1879. He wanted to know what the speed of light actually is. Statistically speaking, that means he wanted to know what speed of light he would observe if he did the experiment over and over again an infinite number of times. Unfortunately, actually repeating the experiment lots and lots of times is just not possible. But as hackers, we can simulate getting the data again. The idea is that we resample the data we have and recompute the summary statistic of interest, say the mean. To resample an array of measurements, we randomly select one entry and store it. Importantly, we replace the entry in the original array, or equivalently, we just don't delete it. This is called sampling with replacement. Then, we randomly select another one and store it. We do this n times, where n is the total number of measurements, 5 in this case. We then have a resampled array of data. Using this new resampled array, we compute the summary statistic and store the result. Resampling the speed of light data is as if we repeated Michelson's set of experiments. We do this over and over again to get a large number of summary statistics from the resampled datasets. We can use these results to plot an ECDF, for example, to get a picture of the probability distribution describing the summary statistic. This process is an example of bootstrapping, which more generally is the use of resampled data to perform statistical inference. To make sure we have our terminology down, each resampled array is called a bootstrap sample. A bootstrap replicate is the value of the summary statistic computed from the bootstrap sample. The name makes sense. It's a simulated replica of the original data acquired by bootstrapping. Let's look at how we can generate a bootstrap sample and compute a bootstrap replicate using Python. We will use Michelson's measurements of the speed of light. First, we need a function to perform the resampling. The NumPy function random.choice provides this functionality. Conveniently, like many of the other functions in the NumPy random module, it has a size keyword argument, which allows us to specify how many samples we want to take out of the array. Notice that it chose 5 3 times. The function does not delete an entry when it samples it out of the array. Now we can draw 100 samples out of the Michelson speed of light data. This is a bootstrap sample, since there were 100 data points, and we are choosing 100 of them with replacement. Now that we have a bootstrap sample, we can compute a bootstrap replicate. We can pick whatever summary statistic we like. We'll compute the mean, median, and standard deviation. It's as simple as treating the bootstrap sample as if it were a dataset. Now it's time for you to do some bootstrap sampling yourself.